We have 3 speakers tonight. Mika Stormbom from Lingsoft, Ilkka Vuorio from AI Matter, and Jenna Kanerva and Lauri Vasankari, who isn't mentioned here, but they're gonna talk about retrieval augmented generation for national security in the end, and that sounds pretty interesting. Yeah, my name is Jani Anttonen, and I come from Vätsky, or the whole name is Varsinais-Suomen Tietojenkäsittely-yhdistys ry, and this is a organization that has been around since 1967, and we are focusing to be the hub for ICT events and networking in the Turku area, and we are building relations to other meetups around the area, and we plan to be the information source, like the single source of truth for events around Turku. So there's multiple meetups, and we have some pretty important people hosting meetups here as well tonight. And yeah, it seems like not all know that there are so many events in Turku area, and multiple people haven't even heard about Turku.ai, and Turku.ai has been around since 2017 or something, and yeah, we plan to fix that, and we are currently hosting the meetup as well, and tonight is being hosted with CIC, Center for Intelligent Computing, and we plan to host events with them for the next year as well. And for next year's events, we're still looking for speakers and sponsors. So feel free to scan the links. I can put these up again, because now we're getting ready for the talks. But yeah, just so you know, and we also got Arttu from Vätsky here. So just hit us up if you want to know more about what Vätsky is and what it does. But yeah, now Mika Stormbom from Lingsoft. Thank you.
Yes, so anyway, my name is Mika Stormbom, and I work as the CTO of Lingsoft, and thank you for joining us here I'm sure you can hear me anyway, right? I don't need the microphone. Yes, thank you. So thank you for joining us today here at Kauppiaskatu in our premises, and I'm looking forward to a great event this evening. And I'm going to be talking about our approach to AI, and then especially the collaboration between human and machine in our workflows. So humans in the loop, if you will. And let me start by saying a few words about Lingsoft as a company. We're a company specializing in AI-powered language services and solutions for text and speech and their intersection. And our focus is on collaboration between human and machine intelligence, a theme that I'll keep on returning to throughout this talk. Lingsoft was founded in 1986 by 2 trailblazers in language technology, Professors Kimmo Koskiniemi and Fred Carlson, and their groundbreaking innovations lay the foundations for what we do today. Fast forward to the present, and Lingsoft is the largest Finnish-owned language company globally, one of the largest Nordic-owned language companies, and at present the only Finnish company of the top 100 language companies worldwide per the latest CSA research report, though it has also been the case for quite some time. We're headquartered here in Turku, so quite literally where we are here at the moment, with offices also in Helsinki and Stockholm. So we offer a comprehensive range of AI-powered language services and solutions, including language services such as translations, subtitling, transcription, content creation more generally. And complementing these services, we also develop different types of language solutions, and including recent innovations powered by large language models. We serve a diverse range of clients across multiple sectors, providing tailored language services and solutions to meet their particular need. We offer translations and content creation services for a variety of European Union bodies, translation, subtitling and transcription services for public administration, subtitling, quality checking, translation for broadcasters and content producers, dictation, transcription solutions for the healthcare and welfare sector, including well-being service counties, hyvinvointialueet, here in Finland. We pride ourselves on having long-term relationships and deals with many of our customers, allowing us to collaborate tightly with our customers and get a deep understanding of their needs and their processes and tailor our services accordingly. With our roots in academia, we've collaborated with leading universities across the Nordics to drive innovation. So these include the University of Turku, Turku University of Applied Sciences, University of Helsinki, Aalto University, KTH, Royal Institute of Technology in Sweden, Chalmers, University of Gothenburg. And I think it's fair to say that academic collaboration has been a cornerstone of our success. A few words about myself. So it's been approximately 19 years since I joined the Lingsoft group of companies, and it's been a great experience to see how language technology and AI have evolved in that time. I began as a coder of accessibility apps in a startup called ImageTalk in 2005, which Lingsoft then acquired the following year. And over the years, I've held roles in product management, language technology development, business strategy. And in different capacities, I have been involved in and led development of language technologies for more than 20 different languages over the years. And for the past 2 years, I've been Lingsoft's Chief Technology Officer, leading a talented team of 30 people stationed across Finland as we develop our AI-powered solutions. And my work has given me first-hand insight into the importance of combining human expertise with AI, and that's a principle that drives everything that we do at Lingsoft. And well, by the way, if it's not evident, that's not me. That's an AI-generated picture created with a fine-tuned stable diffusion model. An experiment not done out of vanity, to be clear, but more out of curiosity about how the generation process works. Doesn't have a whole lot to do what we do at Lingsoft, but nevertheless, sometimes it's good to take a step back and marvel at what is possible with technology these days. But anyway, coming back to languages. So at Lingsoft, we've experienced firsthand how AI and language technologies have evolved over the past 4 decades. It should be noted that AI is a rather broad term with a nebulous definition that has changed over time. I remember being involved in one project funding application around language learning, where we were working on some years back, and where one of the other partners were adamant about referring to the sort of technology selection in the application text, so referring to that as AI, even though the term AI wasn't perhaps widely applied to that particular technology at the time. But the application was accepted, and we went on to do a great project. So I guess it was a good call to include the term AI there. But for the intents and purposes of this talk, what we mean by AI is especially then different types of language technologies. And AI then is an integral part of our work and encompasses a number of different technologies and approaches that have evolved over the years. And from our perspective at Lingsoft, and in terms of how it has affected our solution and service offerings, we have witnessed and participated in several distinct eras. Rule-based approaches is the foundation for what we did here in Lingsoft, and the approach we have used for developing our language analyzers and language quality checkers, so spelling and grammar, starting in the 1980s. The 1990s introduced statistical methods, and for a time that was our choice of technology for our machine translation setup prior to the deep learning revolution, so the rise of neural networks in the mid to late 2000s. And here at Lingsoft, we then also embraced neural machine translation with their superior performance and combining its capabilities with human expertise in post-editing workflows. And overall, much of our language technology stack is neural network based these days. And most recently, though we're still talking about neural networks, we highlight large language models, LLMs, as a big leap forward. We're all in the middle of this transformation, and all the implications will only become clear in time, but it's already changing many industries there, and especially the language industry. And continuing with the example of machine translations, LLMs are starting to outperform the current generation of NMT models in benchmarks, and we'll likely see them replace NMT models altogether in the very near future. And we ourselves work actively with LLMs as part of our translation processes and in our other language processes, and in creating new language processes for new service offerings. So our technology stack reflects decades of learning and innovation, and it's designed to combine automation with human expertise to deliver reliable, high-quality solutions and services. And just to quickly highlight them here, our speech recognition for a number of languages handle both recorded audio and live streams. They're integrated into workflows for transcription and subtitling, both for recorded audio and live content. And we work both with general language models and models adapted for specific use cases and language domains, such as the healthcare domain. On the machine translation side, we have models for some 20 plus language pairs. And in addition to general language models, we work with fine-tuned models for specific use cases and language domains, all of which we can further optimize by incorporating, for example, customer terminologies dynamically. We have a long history of developing tools for language analysis and processing as part of discoverability solutions, and as well as quality checking tools like spelling and grammar checking for multiple languages. And the quality checkers were integral to Microsoft Word for many years, serving tens of millions of users worldwide. So that's quite a decent reference, I would say. Large language models power some of our latest innovations, and we use them for tasks like summarization and content creation, and increasingly as part of our workflows across the board. In the case of machine translation, as noted, they will supplant the current generation of machine translation models within the very near future. We're also integrating techniques like retrieval augmented generation, RAG, for example, to utilize customer style guides and instruction as part of the prompt to the LLM in producing or modifying machine translated text, but also here as part of discoverability and findability solutions. But it's not just about individual tools, it's also about how they work together. So behind the scenes, our AI factory ties all of these technologies together. It's both the name of our platform and the way of working that integrates tools, processes, and workflows, allowing our teams to collaborate and deliver consistent results. And of course, these technologies are only effective when paired with the right processes and oversight, which then brings me to a key point, namely the importance of human involvement. And I'd like to share an example that illustrates the risks of relying solely on technology or involving humans without the right expertise. So this story, reported by Svenska Yle, involves a hospital here in Finland. A patient received instructions for an upcoming visit, translated from the original Finnish into Swedish. If you don't speak Swedish, let me just point out that the translation contained a rather fatal error, one might say. So the patient was instructed to kill the anesthesiologist and the nurse during their visit. And given the current shortage of healthcare personnel in Finland, I think we can assume that that was not the original intent or the intended message there. Now, to be clear, I don't know what the cause of this particular translation error might be, and not going to speculate, but what is evident is that sufficient human oversight was not involved in the process. And that's what I want to highlight here. Not an isolated incident. Some years back, I encountered a similar issue when Google Translate was used to produce healthcare documentation into my language and unfortunately rendering it incomprehensible in the process. Quite a few years back now, and while the results were amusing at the time, it highlights the same idea, namely the need for human expertise remains. So our approach to AI emphasizes humans in the loop because we recognize that success often relies on combining machine efficiency with human expertise. And while full automation can be and will be and is sufficient for many use cases, the areas we focus on demand the critical judgment, creativity and flexibility that humans provide. We're moving past the peak of the AI hype cycle, or the current AI hype cycle anyway, and while large language models continue to improve, the improvements are becoming ever more marginal and plateauing, and it's becoming clear that artificial intelligence is not a magical solution, not a silver bullet. Challenges like hallucination remain significant. Disinformation and misinformation are huge concerns, just to tie it back to my innocuous deepfake from before. And big players like OpenAI are posting literally billions of dollars in losses. Profitability remains elusive. A key concern is also availability of data. So by some estimates, we'll be running out of new high-quality text data for training of large language models, possibly as early as 2026. Moreover, the increasing prevalence of AI-generated content on the web and making its way into the training data may lead to models degrading over time. Model collapse, as we call it. An example also of why reliance on external models can be risky. So OpenAI has a large family of models, including then the previous generation GPT-3 models, and they recently announced that several of those models will no longer be available for use. And simply swapping a model for another might not work out of the box. You'd have to understand the idiosyncrasies of that particular model, and prompts that worked with the previous version might not work with the newer models. So if you had built your infrastructure to rely on these models, you might need to put in costly rework. A key positive development is the democratization of AI. So that is the increasing availability of AI to a wider range of people, organizations, and industries. And this is a significant shift as it empowers more people than to harness the power of AI. As an AI provider, however, it means that having a unique value proposition is more important than ever. The differentiator between organizations is not so much the technology they use, but how they make use of it. But despite advancements, many challenges remain and reveal the limits of AI without human oversight. And to be clear, this talk isn't about making fun of translation errors or being particularly pessimistic about the future of AI. Quite the contrary. LLMs have already transformed the industry and will continue to do so. But their inherent limitations also make clear why human involvement is so important. The effectiveness of AI depends also on the ecosystem surrounding it. This includes reliable data, integration in workflows, user-friendly interfaces, and ongoing monitoring and maintenance, and humans in the loop. So high-quality data is essential for accurate outputs. And while fine-tuning existing models can reduce the need for enormous data sets, quality, of course, remains key. And just as important, though, are the interfaces. So no matter how sophisticated a model is, a poorly designed interface can frustrate users and undermine the efficacy of the model. So clear, intuitive designs and UX are critical for delivering value as well. So, for example, ChatGPT's success wasn't just due to the underlying large language models, but also due to the accessible and intuitive user interface that allowed millions to easily interact with it. And it also needs to fit into existing systems, APIs, interoperability, and scalable designs are essential. Security is another essential element, especially when handling sensitive data. Here at Lingsoft, we design our processes to account for the entire ecosystem, so not just the model itself, but data, integrations, human oversight, so as to ensure reliable, high-quality results. So our approach to AI is designed to combine the power of technology with human expertise. And let me highlight some key aspects of how we work with AI as part of our language services. Customization is a central pillar of our approach. So we're able to fine-tune models for specific use cases and customer domains by combining our proprietary data with standard resources, be it ontologies, industry vocabularies, or customer terminologies. And this ensures outputs that are accurate and consistent. We leverage a combination of different technologies. For instance, in our machine translation setup, we can integrate rule-based approaches with machine learning models, allowing seamless incorporation of customer terminologies. Locally deployed LLMs play an increasingly important role for us, and one essential part of using and instructing LLMs is prompting the model, of course, to get the desired output. With many use cases and models to keep track of, the number of prompts also rather quickly increase, and a well thought out way of handling them is essential. And to that end, we've developed a central prompt bank and prompt service as part of our solutions to make it as easy as possible to create, maintain, and version prompts and sets of prompts for different types of tasks for internal and external large language models alike. Lately, we've been working on integration of the retrieval augmented generation methodologies then to enable us to ground language models in external data, such as customer instructions and style guides. So adding another layer of processing where AI is part of the picture. Data quality underpins effective AI, so we can collect, annotate, and manage language data to ensure robust data sets. Continuous improvement is a key phrase for us here at Lingsoft, so it ensures that our solutions stay relevant and aligned with customer needs. And in essence, it entails regular monitoring of performance and continuous updates and deployment to keep our models and technologies and other parts of the process ahead of the curve and to help us refine and improve over time. Measurability of various aspects of the process is thus essential. And as mentioned, central to our work is the AI factory, which integrates tools, processes, and workflows. And this enables then collaboration across teams, ensuring consistent quality and faster delivery for customers. AI affects our work in other aspects too. So for example, when it comes to code generators or document production, I can't recall the last time I wrote a document without the assistance of one large language model or the other, if I'm honest. But while technology forms the backbone of our setup, it is the human touch that ensures that these systems deliver on their promise. And this sets the stage for our core philosophy. So humans in the loop at different levels in the process, where technology amplifies human expertise rather than replacing it necessarily, and ensuring language services that are accurate, adaptable, and reliable. And a number of different roles and competencies are essential here. So language experts review and enhance, post-edit AI-generated outputs, whether they be translations or subtitles or summaries, just to name some examples. And this has generally been a sequential process. The AI-generated output is post-edited by the language expert in 2 distinct steps that each are performed once. But the ability to prompt or instruct the models to adjust the output iteratively and work with the AI output in multiple iterations, that's a recent addition that will change the way of working considerably in the future. Compare that to conversational user interfaces like how you'd ask ChatGPT or Copilot to produce and modify content and ask for adjustments successively until you're satisfied with the results. Machine learning engineers train, fine-tune, deploy models, and tailoring for customer needs, use cases, language domains. So we put particular emphasis on fine-tuning existing models rather than training models from scratch, which has typically been the case in the past. Prompt specialists as an emerging role, design and refine instructions for the large language models that are part of the process. And this is where our prompt bank becomes an important tool to maintain these prompts. Process oversight is key, so process owners and process developers maintain the end-to-end setup, addressing bottlenecks and driving continuous improvement. To name about a few roles in the overall picture. So while language experts remain crucial, new emerging roles are vital as well. And these roles and the infrastructure are part of the broader concept of AI factory. So not just a collection of tools and technologies, but an ecosystem of processes, ways of working, tools, and people in specific roles. We put a lot of emphasis on developing and maintaining our own models and technologies. A key aspect is the ability to deeply customize our setup to meet customer needs, of course, but there are other aspects to consider as well. Confidentiality is of paramount importance to us. We deal with sensitive information every day, and ensuring the security and confidentiality of that data is a top priority. We believe in technology independence. As a European provider, and especially as a Finnish company, we want to maintain and develop our AI infrastructure locally here in Finland, which not only allows us to maintain control of our technological assets, but then we can also sort of contribute to the growth of the European and Finnish AI landscape. So having full control of the models is important to us. A few words on how we see things developing going forward. So user interface paradigms are evolving with a focus on conversational and multimodal systems that integrate text and voice and visual inputs for richer, more human-like interactions. And multimodal end-to-end models covering both text and speech are increasingly going to be part of the picture and is something that we are actively exploring ourselves. As for the role of the human in the process, the roles have changed and will continue to change as the technology develops, and there certainly will be many cases where fully automated solutions will win the day, and that's completely expected. Our main focus is on human-centered services and use cases where humans do need to be involved. And that has been the cornerstone of our strategy, and this approach has proven successful over the years, evolving alongside technological advancements while maintaining the core principle. By keeping humans in the loop, we deliver, dare I say, exceptional language services that adapt and improve over time to meet our customers' evolving needs. And that's what I had on my mind. So thank you for your time, and I look forward to hearing your thoughts. Yes.
Could you tell maybe a little bit about a concrete project that you're working with here? Give an example of something that you can tell us about.
Sure. So for example, in the case of summarization, we are using large language models, and they're basically following the approach that we always do, that we have AI producing the initial summary, and then we have a human being who post-edits it. So and there we are working with large language models then to produce the initial summary. That's perhaps not a whole lot more concrete, but just to give an example of a recent thing that we've been working on.
But you also said that you mentioned, you said the word locally here at one point, and it got me wondering that do you mainly use local hardware or do you employ some cloud computing?
We make use of both. So we have our own maintained hardware, and then we make use of cloud services as needed.
Okay.
Yes.
What do prompt specialists do in your company? Are they like scientists which are trying to understand what are the best prompts for particular situation, or what?
Well, yeah, I mean, it's about sort of getting the most out of the large language models, right? So it's an iterative thing where you experiment with different prompts and compare the output. Yes.
Yeah, this might be already a bit of an older question, but or like a few years old, but I'm sort of wondering that since you're working on the language model side, and how new was the ChatGPT and the whole explosion of sort of different kind of language models in general use? Like, did that come to you as a surprise, or did you already kind of know that this kind of stuff is being developed, and did it surprise you, or like how did you feel once the current hype cycle sort of started?
I wouldn't say surprised in terms of the technological development that has happened, but perhaps the adoption rate, I think, caught everyone by surprise. And well, as I argued in my talk, I think that was very much about the user experience. It was for the first time like accessible for people in a way that AI hasn't really been before. So some elements of it certainly took us by surprise, and others not so much.
Yeah, it must have been like sort of super interesting for you, especially since you've been working.
It's a very interesting time to live in, to be sure, and it's hard to keep up. It's a full-time job to keep up with all that's going on.
Even for the experts.
Even for the experts.
To maybe continue that thought, do you have any advice on how to keep up with this? Because I've noticed myself that it is very hard.
Employ AI to keep up with it.
Thank you.
Yes.
How do you see the combination of like large language models and just not say small large language models, but like combining these gigantic models with like traditional machine learning models and also like smaller models? Is that something you utilize as well?
Well, we use the whole gamut of things, so more traditional machine learning models, but also smaller versions of large language models. I don't know at what point they become small language models, and how many number of parameters do you need before it's a small language model? I don't know, but yes. Yes.
Maybe continuing this question about the explosion of ChatGPT, I'm sure that the kind of like the view of the market or people who were aware of what was going on grew exponentially, and so how did the business landscape? Because you were specifically doing language stuff, and now everyone is aware that you can translate anything with these tools that are available. So how have you like encountered difference in the business landscape, like especially, and is there like any specific things that have actually changed?
That's an interesting question, because I think as it pertains to the customers we usually work with, they are certainly already aware of machine translation prior to ChatGPT. So I don't know if I necessarily in that sense have discerned like a very noticeable difference. I would have to say I would need to reflect on that one a little bit, but generally speaking, I think quite a few people were aware of like machine translation prior to the advent of ChatGPT. Yes.
Have you had any difficulties with the EU Act and with GDPR to send personal data to perhaps in the private cloud or LLM?
Yes, so I mean that's certainly a non-starter to send it to, for example, third-party providers. So that's definitely something that we avoid. Yeah. Okay. Well, thank you for me. Quite a few of my colleagues are here today as well. So looking forward to continuing the evening. So thank you.
Okay. Let's see if you can hear me. I haven't spoken to a microphone for like 5 to 10 years, so let's see how it goes. My name is Ilkka Vuorio. I feel like I'm probably in a wrong place between a CTO and a postdoctoral or postdoc researcher, but it happens. Here I am. I'm going to speak to you about a little bit about multilingual text-to-speech synthesis. We at IIMater make, or our main product is text-to-speech synthesis in Finnish and in Finnish-Swedish. And often the customers kind of want sentences that are multilingual, at least in Finnish, where the loan words is quite a common concept. The text-to-speech synthesis systems, or let's say modern text-to-speech synthesis systems, can kind of be separated into two different, or probably more than two, but here we are kind of considering on two. So it's possible to take the input text and directly output waveform. That's difficult in sense that one word of input produces tens of thousands of samples on the output, considering that audio is 22 kilohertz or 44 kilohertz. So the number of samples generated from one input is huge. So generative AI-wise, that's problematic. What is quite a lot used is it's kind of two-stage text-to-speech synthesis, where the input text is first generated into a MEL spectrogram, which can be at something like rate of 4 hertz, so 4 samples per second, for example. But it can be, for example, 80 dimensions. So instead of waveform being one dimension, it can be multi-dimension. So that kind of simplifies the process a bit. And then the waveform is turned into, or the MEL spectrogram is turned into a waveform by a different stage. And then considering the input, quite commonly nowadays, at least in English, the input is just text. So the model has to be context aware. So in English, one letter can be pronounced in multiple different ways depending on the context. If we want to reduce the amount of training data, we can move the phonemization. So how do we pronounce this letter in this word to an external service? That, of course, isn't problem-free because the phonemization sometimes might not follow the rules and would require another model. There are pretty decent open source phonemization libraries available, but we will not go into there today. The way to do this for a language that is so somewhat resource constrained, as for example Finland or Finnish-Swedish, we have to, basically we almost always have to use the phonemization. In Finnish, phonemization is not required, as the mapping from letter to phoneme is 1-to-1. But considering that there isn't a lot of training data, it would be required if this weird phenomenon would not apply for Finnish. But in like Finnish-Swedish, it's almost a must. The problem when we have sentences with multiple languages is that the phonemization has to know what language we are phonemizing. For example, there is a sentence the French word for cat is chat. If there is anyone who speaks French here, that's not quite how it goes. Let's see if I can make the sounds work from here. The TV doesn't have audio, so we'll see how it works out.
French word for cat is chat.
You kind of hear it, maybe, in the back? Decent, okay. So, as we see, it's not good. If there would be someone who's French, they would probably throw me with a shoe or something. There is a thing called SSML, which is a speech synthesis markup language, which has a possibility of defining multilingual sentences. This is quite commonly used by, or the SSML is quite commonly used by text-to-speech services, for example, on cloud providers. So if we change the word or the sentence a bit, so that we define that the word chat is not in English but in French, then the phonemization of that word will be a bit different, and thus the output is quite different too.
French word for cat is chat.
So now it's a lot better. The model has not been trained for French, and it's actually using English for this, and that can render it to be slightly off, because the phonemes might not be exactly one-to-one from language to another. Well, as we are in Finland, our main use, or for our text-to-speech synthesis, the main usage is in Finnish. As already mentioned, Finland is very muchly adapting loanwords. So if there is a new technology, a name of a city, anything, usually there isn't a version in Finnish. But we just take the English or whatever the native language on the place or the technology is, and just use that. And then in addition to using the loanwords, we just use suffixes with the words. So we can just add suffixes to the English words as if it was Finnish. And I don't know, that's a bit of a mess. And as I'm not sure if all the people here are native Finnish speakers. My grammar knowledge is bad. This was a picture of Finnish grammar I found, and I don't understand any of it. But let's go through a simple example. A dog. Can't be that hard. Koira. So we can add a couple of suffixes on it. So there is the dog itself, koiran, the dog owns something. Koira, I'm looking at the dog. Koiran again in some other form, but yeah. Koirassa inside the dog, koirasta from the dog, and so on. So there is a couple of them, and a few more. So we just, I don't know, we probably could make a list of what all the endings are, but then if we change the word, the endings might be different. And when we check them here, we just can't consider just crapping the endings off from an English word, because some of the endings are pretty common also in English words. We just add an N That's pretty common. So yeah, that's a problem. So Finnish grammar is our friend, and I love it almost every day at work. So yeah, it gets difficult. If it's only Finnish, no problem. Here's an example in English. They have their own word for the place, or the name of the place. But in Finnish, there is the word itself, and then this weird ending. And we'll get back to this one later, because this is very nasty one. And you can try to guess why it's nasty during the show. And then an English word, I mean, if it was just Washington, would we scrape the N off it or not? Who knows? Yeah. So, to solve the problem, there is a couple of things we can try. We'll go to another place, which is one of my favorites in English, Worcestershire. There is a sauce coming from there, and no one knows how to pronounce it except people who live in Britain. So I can play you the first sample. It's horrible.
En käynyt Worcestershiressä lomallani.
So you can imagine that if this was a sentence in news by Yle, they would not be super happy with this result. One way to solve this is try to write it out as it would kind of sound when in Finnish. But this is problematic because Finnish doesn't have all the phones of other languages. We don't have like sh, for example. So you just try to come up with what you have, and it can be a bit better, but I'm not a specialist on this, so this might not be the best possible way to do it, or the best possible way to write it out in Finnish to make it sound like this. But let's see.
En käynyt Worcestershiressä lomallani.
So how many of you have been to Worcestershire? I don't know if this sounds too good either. The other way of doing it is that we use two different models that we have for different languages, and this is like the classical solution that has been used, and they are okay if it's just one language per sentence, but if there is multiple, then you have to generate different audios and then combine them. It can get problematic because the volumes and etc. of the model can be a bit off, and it takes a lot of manual labor. And it's not super straightforward to get good results. On this one, it wasn't as bad as I was kind of hoping for you to like see how it could be in the worst case.
En käynyt Worcestershiressäkään lomallani.
But there is an obvious like gap in the between, like between the English and Finnish when it's the mid sentence. But you kind of, if you hear that, you kind of almost get a hang of what they're trying to say to you, comparing to the first one, which, yeah. So what we tried to do was to make a multilingual model which contained phonemes from all the 3 languages. So we used Finnish, English, and Swedish. We got datasets from this one speaker. And then it just generates the audio so that instead of inputting a phoneme, we input a phoneme and the language of the phoneme. So basically, instead of it's something like 120 or something there is of IPA phonemes, now we got like 300-ish input phonemes. So there is no like language embedding or anything. It's just we're just adding new phonemes, which is not the optimal way, but it was a test to see how it works.
En käynyt Worcestershirekään lomallani.
Still, Worcestershire is an unpronounceable, and if someone would say me that they have not visited Worcestershire in their holiday, I wouldn't know where they have not been, but it's good because they haven't been there. But yeah, the transition between languages gets slightly better, but it's not everything, or all the problems are not solved yet. Because, for example, I think this is the right way to write. That it's almost right way. It doesn't have the there is a, not a. I'm dyslexic, so give it up. If you haven't visited Göteborg during your holiday, I think this is how it goes. So it's Göteborgissakaan. So you add the letter I in the between. But if you know how Göteborg is pronounced in Swedish, it ends with something that is slightly like between Finnish J and I. So if we give this input, the output will be following.
En käynyt Göteborgissakaan lomallani.
Which again is not too good. I mean, at least to me, it sounds bad because it's Göteborgissakaan, and it's getting mixed up with all the I's and J's and whatnots. So in this case, if I gave it an input without the letter I in the between, it sounds a lot better, at least to my ears.
En käynyt Göteborgissakaan lomallani.
That introduces somewhat of a like, I don't know, something weird, like a scratch or something, and that's probably because of the change of the language. But it's a bit better than en käynyt Göteborgissakaan lomallani. So you can't get everything on the first try. What we found out is that the training data does not have to contain multilingual sentences, and still the results can be, let's say, decent. At least they're better than the beginning. As all this was trained with just datasets of the speaker speaking only single language sentences. Yes, we probably would get better results if we had the language barriers. I don't know how much we would need them and how difficult that would get, but it's something to maybe look into in the future. Yeah, as we saw, the input is still sometimes problematic. Yeah, now the thing is that we have to find the word that is not Finnish, and we have a pretty good system for finding all words that are not, or that if pronounced in Finnish will sound bad, but it flags the whole word from empty space to empty space, and that doesn't really help. Then we would have to still get the suffixes of it. Yeah, so it's not solved, but we maybe took a step. Yeah, and then the pronunciation of how Finnish suffixes are written are not might not always match, as we saw in the Göteborg case. So, what next? We simplified the problem to be a classical NLP problem, and well, hooray, I guess. But because Turku is probably the natural language processing capital of Finland, thanks to the knowledge in Turku University. Now we just need a model that would detect the language of the subword pieces, and I'm not an expert on language models. I'm not really an expert in any of this. But I guess that the subword pieces might cause us a little bit of a problem due to the fact that most of the language models work with tokens. So we might be doomed. But yeah, this is something we've been trying out. This was a exercise that our summer trainee did during the summer. So I want to acknowledge Joona Nikula, who apparently is not here, lives in Helsinki. But if he ever contacts you and asks for a job, take him. He's a damn hard worker. And probably I should acknowledge Kai Hakala also for giving a good tip and good like push in the right direction. Any questions?
You do some stuff at least, Yle, right?
Yeah. If you go to Yle's website or the app, the news are read out by our TTS.
Okay.
Yep.
How does it do it in there? If there's like.
That's basically still based on the this. So someone has to manually write them out in a way that would be the closest in Finnish, and this isn't optimal, but yeah.
So who writes them out like that? Yle or you?
I think it probably depends. There is a lot that is done by us, but I think on new cases it might be that Yle is doing some of it. I haven't, so I don't know. Yep.
A general question: how fast is that like producing the voice out of the text? Is it possible to use it real time?
For this model that we've used, it's called Forward Tacotron. It's a couple of years old, or some years old, let's say. It's pretty damn fast. If you have a decent GPU, I think it's... Antti, do you remember?
It's faster than real time.
Yeah, faster than real time. I'd say it's like 10 to 20 times faster, but that might be the ballpark, but not the exact number. So you can use it, or you could use it in like real time if you wanted to.
Just interesting that if there is like a company Finnair, like how would it say it? Is it like Finnair or Finnair? What is like the design choice? Because I think Finns are not consistent with this.
Yeah, those are the problem. Yeah, real problems, because it depends. Basically, for us, it's the customer who has to make the choice on what they want. Yeah, and in like Finnish Swedish, it apparently doesn't get that any easier because they want to pronounce it different than the Swedes, but still not how Finns do it, and yeah, it's even more complicated. Yep.
You gave that example earlier where cat was translated into French and it was written in this very weird syntax. Is that the phonetic language?
This one. Ah, yeah. Yeah, these are IPA phonemes, so India Pale Ale phonemes.
Okay, yeah. And is this phonemized language, is it universal among the languages?
Yes, IPA phonemes are universal, but so you can phoneme. I'm not a language person. My significant other is an SLP, so she kind of tries to teach me this, and I don't really learn. But basically, you can use IPA phonemes to phonemize any language. But apparently, there is some sort of an issue that the phoneme might sound a little different in different languages. Okay. So it's somewhere between the letter and the phone itself, so how it would actually sound. But it's a bit somewhat language dependent, so it's a bit messy.
Okay, yeah. My question was going to be that could you maybe use the model to somehow predict the phonemized version and then from that get a better prediction on the output? But maybe that answers the question.
But that's something that I've been considering, that if not the actual phonemized output, then the phoneme and the language, or
then you would get the context.
Yeah, because I mean, if it finds this like weird kind of S shape, it sounds a bit different in different languages, if it's in Swedish or English, but it's still probably a lot closer than what it would be now. So it would be like into the right direction. If it would be easy to do, but training it from scratch to phonemizing, it would be an adventure, to say the least, I guess.
Sorry to continue that, but how does these models work with slang words that don't really have a proper...
Next question.
There's a combination words of Finnish and Swedish.
Yeah, that's let's say it's a problem. I mean, probably you could try to split it into pieces, and if you'd use the phonemes, you could just or the phonemes with the language information, you could just pair them up in a way that would sound the best. But it would need a lot of manual work. Yeah. And yeah.
To continue this, if I say jag tar dos antidosis, what would it say?
I don't want to know, and I guess you don't either. Yep.
How much fine-tuning have you done with the text-to-speech models in there?
Most of our models are trained from scratch for Finnish. The problem for fine-tuning English models, at least the modern ones, is that they basically skip the phonemization part. So it takes a lot of training to get it to understand that Finnish is pronounced quite, or each character is pronounced the same way almost every time, or basically every time. So if you ever tried something like 11 Labs, it will sound like Kekerusberg or something. Or who is this person? Yeah. So it sounds like you know Finnish, but you've lived in the States for like all your life, and it's horrible. At least to me. Thank you.
Okay, thanks for coming back, everybody. My name is Kai Mikael Björk. I'm asking for silence. Okay, my name is Kai Mikael Björk. I'm the director of CIC, Center for Intelligent Computing, a AI center for the universities in Turku. And one of the projects it's funded by the city of Turku, and it's hosted by Business Turku, but I sit in the University of Turku in the Tietotekniikan laitos. Anyway, one of the projects I have there is that we have a AI outreach program that was funded by Liedon Säästöpankki-säätiö. And we wanted researchers to go out to companies and to find out what can be done with AI in the companies. And we have a pair of researchers and also company representatives here today. That is the first one of many I wanted to say, but we are about 7-8 researchers that's going to go to 7-8 companies. And we are going to have this kind of program in the spring, so you're welcome to join us in the spring for AI meetups, because the process is that the researcher goes there, talks to the company, and then they come up with something, and this something is what you're going to hear here in the AI meetups. So Jenna from Turku NLP, and then we have Vasankari from 61N here today, and I don't know who is starting, but maybe it's... Yes, so thank you for joining us today, and there's more to come in the spring, but now Jenna and Vasankari.
Thanks for the introduction. As said, I am Lauri Vasankari from the 61N Solutions, which is located in Tampere and Helsinki, which is convenient for an Aboriginal person who lives here. But yeah, regarding I am originally a naval officer from the Finnish Navy, and then I did my time in Aalto University to study data science and AI, and transited to be an AI consultant. These days, after the ChatGPT, everybody is an AI expert, but at least I have a degree on it. And following Jenna shortly, hopefully next year, I have a PhD in AI as well from Turku, hopefully. The topic of the day is the retrieval augmented generation for national security, because the company 61N is focused on defense sector. We do implementations and software services for governmental agencies mainly in national security field, mainly in Finland, at least for now, but for Western allies, possibly in the future, and also the defense industry in general. The offering encompasses management consultation, which means like integration services, vendor bidding, all that, and architecture and concept design, as well as, for example, software as a service solutions and deployable software system projects, with which I mean like deployable as a turnkey project, that you get the software, you get the IP, and that's it. Or then we hold the IP and produce it as a service for future use. The company was founded in 2021, and now we have some 40 people on board, a bit less than 5 million euro revenue this year. So it has gone up quite nicely, not to the scope of Lingsoft, but getting there. We are some 40 years behind. So, and it was not an opportunistic place to bet by the founders, because it was before the attack on Ukraine. That can be said for all the actors on the field currently, because there's a lot of money in the defense sector because of the current political situation, obviously. But the idea behind the company was that they wanted to provide a modern software house to attract people who are interested to work in the field but haven't found a proper job in their particular fields in other, like more, it's devious to say conservative, but let's say legacy companies in the field. So we wanted more agile approach. And then the technology focus is on analytics and AI. Analytics covers most of the AI services that we do and the technology implementation because mainly it's big data analysis and stuff like that. Some large language model projects that were discussed with Jenna, and she will carry on with that. Hybrid architectures, this doesn't mean what you think it means. It means that usually in national security you have classified environments and non-classified environments, and then the classified environments come in 4 shapes and sizes. And then you may need to leverage, say, cloud services in public cloud and combine those results to a classified, let's say, a restricted or secret stage on-prem system, and you need to have some pipeline there to leverage all, or have the solution deployable as a container technology from one environment to another, so that it can operate no matter where it's actually operated, because mainly the data is classified, not the system itself. And in the usual information management and data solutions, naturally, nobody talks about big data anymore. That was 8 years ago, so last season. But there exists data en masse, and it has to be handled. And just, I believe it was today or yesterday, there was an MIT tech review on defense sector. They were interviewing Anduril in the States, and the Anduril representative said that the next global conflict will be solved by the one who processes most data with accuracy and speed. And as a former officer myself, I concur with that statement. Of course, you need to be able to follow up with just, it doesn't really do much if you just have data flow when you're fine with the dashboard, but you need some other resources as well. It's not going to be a software war entirely. But yeah, we also have an eye out for disruptive technologies. For example, quantum. I don't know if I'm allowed to say, but we thought like 2 months ago that we should keep an eye out, more eye out on quantum. Yesterday, Google had the Willow chip thing. 2 months ago, we were like, we have an eye out, like left eye. And now it seems that it might be here sooner than later. So one has to be prepared. However, the meetup with the Turku NLP PhD Jenna went so that she came to our office in Tampere. There were a few experts from our side, mainly people from the projects that had implemented large language model solutions, as well as me, because I was the contact point for that, and some kind of an AI specialist. And there was one person from Forge Digital, which is a sister company, a data scientist who had worked in her previous post with large language models as well. And the agenda consisted of going through existing envisioned application areas and projects to leverage the large language models. There's a dashboard or leaderboard from yesterday of the different models, and it's, as said in the first presentation, it's a bit difficult to keep up with the development pace and what good model is good at what, and when and how to employ, and how large is it, and what does it require to be run where, and all that, and how much data does it need, how can it be fine-tuned, and all that. That was the focus. The problem areas are mainly the classified environments, because that brings on-prem requirements. You can't have the largest, 400 billion parameter llama model function on your Fujitsu computer, even though it might be the best. And the applicability and scalability of current large language models, I had the idea that the smaller models might compete in performance, but Jenna proved me wrong there. And so there was the major part of the discussion was on the scalability and the usage of leveraging large language models, and I mean the very large ones, because they outperform the smaller ones, at least for now, unless there's some technological innovation there. Don't think that might be the case. Jensen Huang said just today that they need to scale up the computation up 1 million times, or what was it, the number? Of course, he's selling the shovels to these gold mines, so that might be the motive. However, another part was the reliability, also pointed out in the first presentation that the hallucination and reproducibility is a central requirement for, let's say, military applications. You can't have hallucinations if you're processing documents that they need to be exact. If the output is very creative to the user, it might be detrimental to someone else or the user. And therefore, the retrieval augmented generation solutions for accuracy and citations and all that came to be. The picture is from a scientific paper that was discussing ethics in AI, but also highlights the problems such as the hallucinations. And then the domain-specific corpus and context, because that becomes also not in a sense like the phonemes, but in another way, comes in a way. There's a recent paper from this autumn that highlights the fact that large language models don't necessarily fit per se for military context because the jargon is weird. Same words have different meanings, the context swaps, and there are a lot of acronyms and all that. And as it's token-based, it requires some fine-tuning. How much training data is required for the fine-tuning to come up with non-hallucinating models for defense purposes? How can the fine-tuning be done? How can the fine-tuning be done if the computation is limited to on-prem requirements? And then the language barrier, because there's a limited amount of Finnish, Swedish data to be used. I believe it's mainly already been used, and versus English and the larger models. Fortunately, the larger models perform quite nicely, even on our small language areas. The application areas that were, I can't tell the customers or the actual projects, but just to get the idea. Unfortunately, the Prime Minister's office in Finland had a project with, I believe it was Silo.ai, who provided the project. They wanted a summarization tool for, what's the lausuntoyhteenveto? Like statement summary retrieval. I believe it was for legislation purposes. The exact same problem area exists in the military where you need to, or would be nice if you could just summarize a large number of documents. Because say you get a new lieutenant for a NATO country, he arrives from Spain, he has 2,500 pages of documents to ingest before the next brief, which is at 10. And that can be an issue to people with limited cortex. And therefore, it would be performance enhancing to have a reliable tool to summarize the situation. And this is very applicable to the multi-nation environments, but also nationally. And the assimilation to new tasks, that was what I was just about. But all over the working efficiency, because it has been said that military organizations, not to deem the military per se, but it has been said that military organizations write a lot and read a little, which highlights the point here. To make the reading amount smaller would maybe enhance it. And the accuracy and correctness of information plays a major or crucial role, depending whether it's like a purely managerial or bureaucratic role of military personnel or warfighting role where it's obviously crucial. And then the analyzing of open source data en masse. We have a project on that, leveraging cloud and providing analytics from there, and that is easiest to deploy with large language models. And that's a probable future project to assist in generating documents when fitted to the corpus of the domain, so that it could enhance the working force in defense organizations. But that's all from my side, and now Jenna will get to the dirty details of retrieval augmentation. Once I get...
Hi, my name is Jenna Kanerva. I'm a postdoctoral researcher at Turku NLP, University of Turku, and I'm gonna tell you some details about RAG solutions. So basically trying to present what kind of technical solutions could answer some of the questions presented by Lauri based on our discussions during my research visit to 61N. I'm sure many of you know what retrieval augmented generation means, but to give you like some principles is that often you would like your model to be informed about your own in-house data, which may not be public. So imagine you have some large amount of military documents and you would like to apply your model on those documents, but you cannot like show these documents to anyone or something. And many like actors have large private collections of data, so it doesn't need to be like secret documents. It can be like basically any company documents which are not available publicly, where you can apply such solutions. So posing the question to public or general large language models will provide you answers based on like public data. But if you would like the model to answer based on your own data, then the answer can be different. As a like quite silly example, but you can kind of have a general knowledge that like 1 + 1 is 2, but what if your document says that 1 + 1 is 3 and you would like your model to kind of use the information from your document to provide the answer, and in some cases it can be contradictory to the general knowledge, and you would still like the model to produce like the answer what is in your document. And retrieval augmented generation is a basically solution for that, where it's like effective way of kind of using your own material to provide the answers. Here is an outline of such system where you basically have two parts. So the first one is the retrieval part, where you basically index your own in-house data to some kind of a database. The user has a question or like something you would want to know from the data. You ask a question or have a search query, and then you retrieve relevant documents from your database, give these relevant documents to the generation part. So imagine now you have found like, for example, 10 documents from your own database which are relevant for the user query. Now you give these documents to large language model, which will then give you like the final answer. So in the model prompt, you just like input these your own documents, and based on that prompt, the model will then generate the actual answer for you. And on this talk, I will mostly concentrate on the retrieval part. So I will tell you what kind of models there are to implement this retrieval part. And then at the end, I will shortly get back into the generation part as well. So retrieval nowadays works on text embeddings. And embedding is basically just a dense vector representation which started from the word embeddings. So you have a vector for words so that you can measure simple word similarities. And then if you kind of go further from the words, so not just having an embedding for single words, you can have sentence embedding where you embed the whole sentence, so you represent the meaning of the whole sentence as an embedding. And text embedding is just a generalization of that, where like you can have any number of words or sentences and you produce one embedding for that segment of text. So there, like the text can be single words, it can be sentences, or it can be full documents, or anything between these. And generally, the history of creating text embeddings goes first from taking an average of word-to-vec word embeddings, which then represent any amount of text as a single embedding. So you just average the words. After that, there were the contextualized language models, like BERT-style models, which create you a contextualized representation of the word. So you give it, for example, sentence, it produces an embedding, contextualized embedding for each word, and then you can take an average of those contextualized word embeddings. And now there are many dedicated embedding models which are specifically trained to this task of give to give a meaningful text embedding. And I will tell you something about what these models are and how they are trained. So this goes now back to kind of these pre-trained language models without any task-specific fine-tuning, so for the like BERT-style models. And here, like as I said, like you just apply pre-trained language model and somehow take the embedding or get the embedding from that. So the pre-trained language model can be anything. It can be encoder or decoder model. So you can take a pre-trained BERT, Roberta or GPT or Llama model, basically any language model, and somehow obtain the text embedding from that. There are two common ways. So you can use an embedding of the special token if that is meaningful. For example, in BERT model, there was this CLS token, which is during the pre-training kind of trained to give a representation of the whole text, and you can use that. Or maybe a more common way is to take like the average of these token-wise embeddings. So when you run the BERT model, you give it the text, then there are these self-attention layers which produces a contextualized embedding for each word, and then you just average those. But if you want to have something which is specifically fine-tuned to this task, then you can do that. And maybe the most known of such method is sentence transformers. It's already some years old, so it's not the best method anymore, but it's something most still knows by name, so like sentence BERT or sentence transformer. And how these work is that you start with any encoder, pre-trained encoder or decoder model, and then you fine-tune it to this embedding task, usually using Siamese network and contrastive learning. And Siamese network basically just is illustrated here. So it means that you have your user query and then you have your target document. You embed these both basically using a same model. So here it's illustrated as two models because it's easier to kind of visualize that you embed the user query, you embed the target document, and then you compare like the similarity of these embeddings. And when you share the weights, so you actually just have one model, but to embed these two things using the like same weights, and you train that, then it kind of learns to embed like the user query and the target document in a meaningful way. And the embedding from this is obtained again by using some special token. Now this is fine-tuned, so you can decide yourself whether you want to use the special token, and it will kind of learn to put the meaningful representation there if you want so, or whether you have, again, do some like average pooling. So again, you take the average of the token-wise representation, or you can do something more clever as well. For example, applying the attention, to learn attention to somehow select which of the tokens are most meaningful for this input data. And then it kind of learns basically to do a weighted sum of these tokens. So it kind of learns which tokens weights more to this input. But the idea is the same, that you again like have this token-wise representation and somehow you pool these into single vector. And so you have this Siamese network, and then the training is done with this contrastive learning, which means that you have training examples of positive and negative pairs, and what these pairs usually are in text. So for example, you can have a question which the user wants to be answered, and then you have its either directly its like answer or a relative or like relevant document, which like this document contains the answer, and that is like a pair. So you want to embed the user query, and by comparing the embeddings, retrieve the relevant documents for this query. Or you can have this on sentence level, so you would, for example, want to find similar sentences. So user inputs a sentence, and then you would want to find its paraphrase. So you should have a model where the model gives very high similarity to paraphrases. Or you can maybe want to find its translation, so it could give or should give a high similarity for translation pairs or entailment pairs. So basically pairs of semantically similar texts. Or then you can have a title and abstract pairs. So for example, you would be looking data by giving some title, and then the model would return kind of relevant abstracts of that. In training these models, it doesn't matter that much kind of what exactly these pairs are. If these are somehow semantically connected pairs, the model will learn to like rank semantically similar pairs higher than like negative pairs, where negative here means that it's like the user query paired with like basically random document, which then like the pairing doesn't make sense, so it should give a low score for that pair. And how contrastive loss is, what it means is that when you have these pairs, so you have the positive pairs, the user query and the correct pair, and then you have the negative pairs by giving the user query and some like random negative ones. And then here is like the formula for the contrastive loss, but you don't need to read it if you don't want. But how it basically means that you define some similarity metric. In this paper they use a scaled cosine similarity. So you have two embeddings and you can measure the cosine similarity. Then you have this positive pair and bunch of negative pairs. You score each of these to get like similarity of the correct one and of the wrong pairings. And then you have like a list of similarities. And then you basically turn this as a probability distribution by running softmax. So you normalize these similarities using softmax, and then you can use basic classification loss to train the model. That's like what contrastive loss and training means. And that's about how you would train such embedding model, and how do you then evaluate like how well your model works is typically done using this Meetup benchmark, which is a very huge benchmark of having different data sets for different languages and different tasks. And even if the numbers are very large, you should note that many of these tasks and datasets exist only for a subset of languages, and it's dominated by English. So even it has very many languages, it's basically most English. And there is a leaderboard where you can kind of follow these different embedding models, how they do on this benchmark. And here it's just a summary of the datasets where you can see that it has very different kind of a task. So not just like retrieval task. There is a very many datasets for retrieval, but then there is also clustering, semantic textual similarity, also classification and so on. And here I just highlight the current leader from that Meetup leaderboard. But I note here that this leader is like best English model. So that doesn't mean that this is the best model for every languages. And actually from the leaderboard you can kind of select whether you want to get the ranking by English or by some other language. And the results for other languages are not as good as for English because there are fewer datasets, and there is like by different languages has different rankings. But if you would like to do some multilingual embedding, then I would start with maybe these two candidates. Like there is this Voyage model family, which is a company-owned models. So it's like closed model and API-based, so it costs to use those. But if that's okay for you, the results generally look quite good. Then there is this one open weights model, which I haven't had time to test yet, but it ranks quite high on the leaderboard, so I would start trying with that. And I think I will skip most of this NVIDIA's embedding model, but basically just saying that it's fine-tuned version of the Mistral 7B decoder, and it's fine-tuned to, during fine-tuning they kind of removed this causal attention mask of a decoder, so they actually make the model encoder after the pre-training phase during the fine-tuning. Just a small, quite nice detail. And they use this, the mean pooling is replaced by attention. So when you kind of have these token-wise embeddings and you need to create the one embedding for the whole text, they have a, like learned attention there. And they use the contrastive training as before, and trained on a large number of public dataset. So many of these embedding models are trained on like private dataset or GPT-4 generated dataset. But this model says that it's only trained on a public dataset. So basically we should be able to kind of replicate something like this. And then I go back to the kind of to the actual RAG solution. So now we have some knowledge how to make an embedding model. So when we have the embedding model, we can build the RAG by combining the embedding model and then any generative LLM. And here you need to keep in mind that while these like generative LLMs are very time and resource consuming to use, the embedding models are quite fast. So you need to embed your database only once, and then you have a database of these vectors, and querying the database is very fast. There are many like tools which do that super fast, even if you have millions or hundreds of millions vectors in your database. But then when we go into the RAG solution, one kind of question I think is important, especially if you would like to have like your model to be very reliable, is that whether you actually need this generation part, or would it be enough to only have this retrieval part. And on top of the retrieval part, so when you have find the relevant documents, you could apply some extractive question answering style of a model, which is not able to hallucinate as like the generative models are, but it only kind of, it's trained to highlight where in this document the actual answer is. So it's trained to predict like the start and end offset, so, which means that it cannot produce any facts itself. And that would give like for the user quite easy access to the actual data, so where this answer comes from, and then the user verification would be a lot more easier than like trying to check some generated answer, that where this data actually comes and is it correct. So if you don't actually like need some creative generation, maybe extractive solution would be best. But then if your application require like summarizing long documents or like deriving conclusion from a large amount of documents, then I think that like the generative model is the only way to achieve this, because these can only highlight like small part of the documents. And then to the language question, so which models can actually support other languages than English? Most of these embedding models are trained mostly for English, and most of the generative models, even if they say they are multilingual, the official list of supported languages is quite small. So for example, llamas do not officially support Finnish. They do quite well on Finnish, but that's not like what they officially say. And also the Gemma models are quite good on Finnish, but I think they officially say that it's meant for English only. So even if the model is multilingual, it doesn't work on all languages. And these open weight models are quite good on some tasks using Finnish data. So they seem to be quite competitive on like understanding and extracting data from Finnish text. But then when you go into the actual generation, you start to see that they are having some problems. So for example, some llama models, when they generate Finnish, they seem to combine subwords, which doesn't like make a real Finnish word. So you kind of see that there is some fluency issues when the model is generating Finnish. And the situation is even worse for smaller languages. So if you would need something to work on like some Sami languages or something, then the situation is a lot worse than with Finnish or Swedish. And then same goes to like some target domains, as Lauri mentioned. So when you go from general language into military language or something like that, then that is also kind of language of its own. So the model may not know the special vocabulary of that target domain. Yes, that's all. Thank you.
Can I ask a question? If I build a RAG model with my own data, what happens over the year? Let's say I use it a year and then I realize that 10% of my documents have become obsolete. So what is the technique to maintain that kind of, like, do I need to rebuild it from the scratch all the time, or how do I maintain it?
It basically means you need to maintain the database of your background documents. So your database will be like embeddings of the documents or like embeddings of the segments of the documents. So if you want to remove one document from your database, that you just need to remove its embedding or then upgrade the document and embed it again, or like embed like the new updated document. But it's a lot easier than what you would need to do with the generative models, where you kind of would train the generative model on your data. And then if you would need to update it, that would mean that you need to start the training basically from scratch, because the model would need to kind of forget the previous information and learn the new one. So in that sense, keeping the RAG system up to date is a lot easier, because there you have a direct control for your database, and you can simply remove some of the documents from your database or re-index part of your database.
How good are roughly state-of-the-art RAG systems for Finnish with comparison to English, open weights or fully open?
That is an interesting question, because I don't think we have any standard retrieval data set for Finnish where we could measure this like objectively. So that's difficult to answer, because like it depends on the use case, and yeah, I don't think we have data for that.
Sure, but what's your sense? So, I mean, just very roughly, there's off-the-shelf solutions for English that are near perfect for like your everyday purposes. Can you get anything like that for Finnish? If you put together the best parts? No.
Yeah, I don't have any use case where I could like say say because we haven't indexed a large amount of Finnish documents using like these state-of-the-art embedding models.
Yeah. That was actually a follow-up question. If you don't mind me continuing, does anybody train these embedding models in Python?
I don't think there are any models after the Finnish sentence births, so not in like the like past few years, no. And I think it partly comes from the data situation because like most of these training data sets are for English only, and we would need to find a way to create something similar for Finnish, which I think can be done because most of the English ones are somehow automatically paired as well. So like if you take Wikipedia titles and Wikipedia like first paragraphs, that creates quite a reasonable training pair. It then just means whether we can get enough of these pairs for Finnish to train a Finnish embedding model.
All right, thanks.
Did you notice any like degradation of the quality in domain-specific areas? If it was a problem for the generative model, was it a problem with the embedding model? Did you notice the results could be less of the quality when in?
Yeah, to kind of answer from this context, like we had here, we haven't actually done anything concrete yet. So this is based on just like discussions and plans. So I don't know yet, or we don't know yet. Or do you, Lauri, have any?
Just worried.
Yeah. There was the research paper I mentioned that had noticed the domain difference with English.
Yeah.
But I believe that's the first on that part.
Yeah. Okay. Cool.
Thanks, Jenna, Lauri, all the other speakers for tonight. And there are the links. There's a lot of talent in the room. I've noticed, and I think everyone's noticed that. So please apply for presenting or sponsoring or hosting events for the next year, and we really need you. So please do, and let's continue downstairs at Old Mates. You're all welcome there if you want. Otherwise, have a good night and thanks for coming.